Now let's move on to exception level 2 during the boot sequence. So in the previous lecture, we explored how the transition is moved from the bootloader to Linux kernel. Bootloader to first bootloader to second bootloader, from second bootloader to Linux kernel. As you know, after part 1, the execution starts with the bootloader. The control is the path from bootloader to the first bootloader, but at this moment, the bootloader and first the bootloader is running at exception level 3. Then the first bootloader is to load the image of the second bootloader and to make it executable. But at this point, the second the bootloader can be running at exception level 2. So we have the important question. So why the second the bootloader can be running at exception level 2? There is important question. The reason is that these days the different software stack can be running at each exception level. So that it include exception level 3, exception level 2, exception level 1, and exception level 0. So exception level 3 can be running the secure monitor, then at exception level 2, hypervisor can be running at exception level 1, Linux kernel can be executable at exception level 0, the user application can be running. And the several system registers that is suffixed with EL2, and this system register can be configured at exception level 2. Then for this operation, those assembly instruction should be executed in the bootloader. So after this instruction is performed, second, the bootloader will start to run at exception level 2. So let's analyze this assembly routine. Here, after this assembly instruction, the X register has the entry address for this label. This label is available inside second bootloader. That is entry point for the second bootloader. And then after we run this assembly instruction, the value of the X register is written to EL3 register. And then here is another assembly instruction, that is move assembly instruction. So this the bit binary value can be copied to X register. The important point is the binary value represent the exception level 2. As you know, the 0 to the third bit inside the SPSR EL3 register represent the current exception level. But this binary value indicate the exception level 2. So please pay attention to value, this value. This value represent exception level 2. And then after this assembly instruction, so this binary value can be written to SPSR EL3 register. So before running ERAD assembly instruction, the two individual system register, so EL3 register and SPSR EL3 register is configured. So when running ERAD assembly instruction in the first bootloader, then ARM core will perform the two tasks at the same time. So program counters is jumped to this address, and then the exception level is set to exception level 2. So this kind of assembly routine can be performed during the boot sequence in order to start the second bootloader at exception level 2. So once the bootloader starts to execute, it will perform another advanced the initialization work. So it will initialize the fundamental, the peripheral devices, and then configure DDR. And then main responsibility of the second bootloader is to access the device tree, then it will load the kernel image. So this lecture we got to know how the second bootloader can be running at exception level 2. The next lecture we will explore how the kernel image can be loaded in the second bootloader.